All right, so welcome everyone to the LoRa Alliance webinar on building secured and interoperable LoRaWAN devices. This is a deep dive into the TR007, the technical recommendation number 7 we published earlier this year. So first, let me introduce myself. I am Julien Catalano. I am the Technical Committee Vice Chair of the LoRa Alliance, and I'm working with Curlink, one of the founding members of the LoRa Alliance. So let's get started with a bunch of housekeeping notes. So you may submit your questions at any point in time in the Q&A session, and we will address that at the end of the talk of Paul. I will introduce Paul just after. So this session is recorded, so you will, and it will be available on demand. So we will share that after the event. If you experience technical issues, try refreshing Zoom, check your internet connection. We've been testing that, it's working on our side. So the slide decks and the additional resources are in the resources screen. So no chat, no poll features on this webinar, and go to the resource for also the speakers information. Okay, so as you know, this is the LoRa Alliance webinar. So welcome everyone to this webinar. We try to do several a year, so I hope you enjoy that. We are a global and non-profit alliance. We were launched more than 10 years ago in 2015 by a bunch of members, including my employer, Curlink. So we are developing and maintaining the LoRaWAN standards, the LoRaWAN specifications, which are also recognized as ITU, as official international standards. So our mission is to educate the market about LoRaWAN technology, obviously, and that's what we do today with this webinar, and also with the latest advancement and active deployments. Okay, so we also develop and maintain the certification program, which is on the link there, LoRaWAN certified devices. And so you can certify your device, and this is a key point of also building strong devices with LoRaWAN. And finally, last point of that slide is that every LoRa Alliance member are expert for deploying LoRa IoT solutions. So if you want to join us, click the link and please join us. You will have a very nice community around you. Next is about, so I will introduce first how we work in the LoRa Alliance in the committees. So the chart is very simple. We have a board of directors which are heading the work, and we are divided in three main committees. One is the certification committee, so I touched base a bit on that with the certification program. We have the marketing committees working on all the promotion and all the active marketing of the LoRaWAN brand. And finally, we have the technical committee of which I am the vice chair. And this is where the technical work happens. So this is where we write the specification. And each committee is divided in working group and task forces. So I will show you a bunch of them because actually what we will present today in this webinar is really related not to a single group like we did for firmware update over the air or for other webinars. This one is more spread on multiple groups of the LoRa Alliance. So you see, this is what I like to call the GC and the NC flowers. So this is all the working groups in the technical committee here, where you get the security working group, which is a very large part of what this document is about, the technical report 7 about device making a secure device, LoRaWAN devices. The FODA working group is also part of ensuring the firmware update over the air to the device. If I go on the left, the regulatory working group is also something very important when you design devices. And if I go straight down the link layer here on the downside of the technical committee is one of the core specification, of course, which Paul will talk about. Of course, regional parameters is something which you will face when you develop a device. So this is important that you do that well. And we have also a group about polluting device, which something we would like to avoid. And this is really the core of this talk, is how not to build devices which will pollute the spectrum. On the marketing side, there are also working groups which are really involved in this presentation and in this work, and specifically the Device and Solution Maker Forum, which is a forum. And if you join us at the Alliance, you will be able to participate to all those groups. Any level of membership will allow you to hook into all those groups here on the flower, and especially the Device and Solution Maker Forum, which is a specific place for makers, so solution makers, device makers, to share their experience and to contribute to the standards. Okay, so what you will learn today, two things. You will learn the best practices when you implement a LoRaWAN end device, and you will learn also the best practices when you run a network, a LoRaWAN network. And the perspective are also twofold. One is about security. So this is very important to implement security the right way in LoRaWAN devices. And one other perspective, another side of that coin, is about the clear network access, safe network access, and not polluting the network with bad behaviors. So to talk about that, let me introduce Paul Pinault. So Paul is one of the part of one of the members of the LoRa Alliance with the Helium Foundation. And Paul has been with us for a long time now, and Helium is actually a board member of the Alliance. So I guess he will do a better job than me to introduce himself. So please, Paul, the floor is yours.
Thank you, Julian, for this transition and presentation. So yeah, I'm Paul Pinault. I'm part of different entities. So I'm representing Helium network in the TC. I'm also working for Ayrton, where we are designing devices and product basically. And I'm also known as DIS91 as a device maker. So basically today I'm gonna share something like 11 years of device LoRaWAN device development, and hope that it's gonna help different device maker to make their own device the first one or progress in their practice. If you can go to the next slide, please, Julien. So I want to start by a short architectural view of LoRaWAN, just to make sure we have the same vocabulary, the same understanding. So today we're going to talk a lot about devices, but in fact, devices in a solution always work with an application. And that's something important to consider when you make a device. You will always have an application at the end. And so you have to put in place some commissioning process and some other thing we're going to talk about. In the middle of this, we have a network, and the network is composed of two elements, gateways or hotspot on Helium, and a LoRa network server. I will call it LNS for the next, is more easier. The role of the LoRa network server is to implement the protocol and basically to route the right device data to the right application server, to make it simple. So let's go to device development. Next slide, please. So if you want to get started a new development, there is one important thing to do, is to find the right protocol stack. And before that, I would say it's my third bullet point, but it's really important if it's your first LoRaWAN development, or even if you already developed a device but you didn't read it, it's really, really important to have a look to the LoRaWAN link layer specification. So it's a TR007. It's not a big document, it's not hard to read, but it's really something you need to do to really understand how works the protocol and how do correct implementation of it. There is the RP002, which is the regional parameters. We're going to talk also about this a bit later. So once you have this and you read this, you have to find the right version of protocol. It's currently the 104, which is really recommended. So do not start a new development with 102 or 103. Their stack are outdated. They have some security consideration. So it's really better to start with 104. And currently, I say do not start with 1.1, even if it looks like the last version, because all the LNS does not support it, or all the network does not support it well currently, and some evolution will be made in the future, in the short future. So to implement the stack, you won't develop LoRaWAN from scratch for sure. What is important is to use a library that is certified for your development, and there is at least 2 libs that are really common. The first one is the LoRa basic modem. I would say that is a reference implementation of the protocol, and you have also radiolib, which is more and more used on this area. Please, if you look on the internet, maybe you will see a lot of reference to LMIC with Arduino project. Don't use this stack. It's really outdated stack stuck in 103. And I don't know if there is some patch made, but I'm not sure of this. And so I don't recommend to use that one. It's now outdated. When you start developing, I really not recommend to copy and paste example. I don't recommend yet to use Claude, ChatGPT, and others for one simple reason. Currently, the code stack you find on the internet is mostly code developed by people for making a thermometer for home on a weekend. I'm the first one to publish such a sample code on internet, and it's really not professional approach. When I do a professional device, in fact, I don't really share it on internet. So basically, the LLM are learning with hobbyist code more than professional code. So really be careful with this, actually. It may change in the future, but today, take care of this. The last point I want you to take also into consideration is not to develop your device on your side alone. As I say, device come with an application. It's really, really important to be in touch with your cloud team or application team or customer application team if you're just a hardware provider, to understand how you're going to implement the process and what are the processes that you need to implement into your device. To make the link with this, we can go to the next slide, where one important process is about the commissioning of a device, because your device will be at a moment commissioned to the network and commissioned to a LNS. And to commission a device, I mean, the most common way to do that is using OTAA. And for this, you have 3 different credentials: the dev UIs, joiner UI, and the app key. The 3 credentials are not really nice to set up manually into a console. So the best way is to use the QR code identification. So you can have a look at TR007 to get the details that really simplify this commissioning to the network. For the different credentials that are used, so dev UI, joiner UI, one thing which is really important is to use AUI64 manufacturer-owned blocks. It's really important that you own the AUI64 that you are using for your device. Otherwise, you are going to create conflict on the network, and that's, I mean, can be a problem. And we're going to see some example of this. And the last point about security, which is really, really, really important, is the app key. The app key is a secret. It's like your PIN code for your credit card. So do not put it on a sticker on the device, and don't reuse the same secrets for every device. You have to select a random number, and this random number can be obtained in different way. You can have a pseudo-random number generator. The risk for this, if that is someone is finding the seed and the algorithm, potentially it can recreate the sequence. Or you can use a derivation from a master key with a cryptography system. In that case, you won't have the sequence issue, as I said, but you really have to take care of your master key, because you can derive all the keys from that. So that's important point to consider at the beginning of your project, not at the end. Otherwise, it can be an impact. Can you go to the next slide, please? And so this credential says they are the most common use for OTAA joint procedure. And basically, when the device join, it gets other device which are session device. To make a parallel, it's like in your computer when you have a DHCP. So basically, your computer connects to the network and you get an IP address. So it's a kind of mechanism like this. So OTA makes a device getting a network S key, which is a key used for authentication, and an APPS key, which is a key used for the encryption. And as in DHCP, that's why I made this parallel, you get a dev address, which is an address on the network. And this address is not a random address. It's provided it's related to your net ID, which is provided by the LoRa Alliance. And the net ID gives the network ID, and the network ID gives a dev address from. So basically, the address your device is obtaining by this mechanism is really associated to the network you are reaching. So it's exactly like I say, a kind of DHCP to obtain your IP address when you are on your computer. And it means that you cannot change your computer from a network to another network without updating this address. That's an important point. So there is a second mode that is not OTA, so it's kind of static addressing, which is ABP. And an IBP, basically your device is directly set up with a network S key, an app S key, and dev address. We're going to go to the next slide to see what impact it has. Why I choose OTA or ABP? And the question is, if I develop a device, do I have to develop a device supporting OTA on ABP? In fact, it's not a question. When you develop a device, you have to support both. OTA is really the standard. It's the solutions that allow your customer to join your device in multiple networks and also to move a network from another quite dynamically. In certain conditions, it's up to your customer to select to use ABP instead of OTA. And it makes sense in certain specific situations, like if you want to make a TX-only device. So with no downlink communication, this is possible with ABP because you don't have the join process and the join join accept, sorry. And it can also make sense if your device is really in a noisy environment and so not able to get the downlink. So you want a kind of TX-only device, and ABP can be a solution. But when you select ABP, you must have in mind that it has some impact on the hardware at first, as every frame in ABP will conduct to have a write into your flash memory for the frame counter. And this can means hundreds of thousands of flash write at the same memory if you don't have a correct and optimized driver. And this can really destroy the device flash. So you really have to pay attention of this part if you want to make a device using ABP. And as a security aspect, it also reduces the key rotation because you only have one session. So basically, by default, it's a single session. Next slide, please. Bad things I have seen on a network, just to say why I say this and why it's like going an open door. It's because when I look on the field, I see some really strange things. For example, I have a device maker which is always providing the same join UE and app key for the device to their customer, and the customer is reusing them. He changed the dev UE, but maybe he did not read the specification, and he forget one important thing. It's basically the session key are based on the join UE and the DevNonce, and so as a consequence, every device when they are connecting for the first time and the second time and the third time and so on, are generating the same network key and apps key. So basically, it's totally ruin the security. And worse than this, as we can mutualize a dev address, we can use the same dev address for multiple devices thanks to the network key that allow to differentiate the traffic. Here, as we have same dev address and same network key, basically the LNS is not able to separate the traffic and basically route all the traffic for a dev address to the same device. So at the end, for my customer, there was like 100 of devices with no data and one device with receiving all the data. Just to let you know that I don't know how we can make the invoice of water because it was in this domain with such situation. So everything broke the business objective of the device slot just because they did not care about the credential. We can go to the next slide. We know another experience. It's the same device maker, unfortunately, but instead of using the same credential for all the device, is reusing the dev UI for different customer. And basically, maybe it has worked a bit well like this. But in fact, the consequence is when two customers, so two of my customers, try to register different device with the same dev UI on the network. And for sure, it was impossible to do that. And so my customer have just one solution, is to trash the device and get another one, just crossing finger to make sure that it has not been already registered by my other customer. So you see that, I mean, it looks like simple, but the impact is really important if you don't correctly make this commissioning. You can go to the next slide. Please, and jumping to the multiple regions. So I tell you that there is region, and that's really important. And you already have to consider this when you develop a device, because I mean, sometimes you develop a device for European territory, and after you want to deploy it in the USA or the opposite, and it really have an impact on the way you develop the device, because the stack is managing the rules in between region, but these rules also impact the behavior of your device. So, for example, in Europe, the main driver is a duty cycle. So basically, a device is able to transmit 36 seconds during 1 hour and must not exceed this time. In US 915, it's different. We have channel hopping, and the main impact is that for every channel, the maximum occupancy is 400 milliseconds per 20 seconds. So what does it mean? It means that if you develop an American device and you want to deploy it in Europe and you don't care about the duty cycle, basically you transfer like a message every 30 seconds in the USA. That can work in DR0 in the USA. But if you do the same thing in Europe, in fact, you will have the first 8 messages because you have 8 channels. So the first 8 messages that will be fired every 30 seconds. And after that, you will have nothing during the next 20 minutes. This is just due to the respect of the duty cycle. So basically meaning that you're going to lose a lot of messages, and you won't understand why, but here's the reason. At the opposite, if you have a European device and you want to deploy it in America, and in this case, you choose to have a DR0 and your payload is like 15 bytes, it will work in Europe, no problem. But if you go to the US, as you have the 400 milliseconds, only 10 bytes can be sent in DR0. So basically, the frame will never be sent. Let's go to the example of this, because I made it, this error. I made a tracker. And I mean, I read the documentation, so I didn't know that the tracker have to have a limit of 10 bytes for US 915. But what I forget for the tracker is that the stack also can add some extra payload, and it's Mac command. And what happened in my device is I joined, that's okay, perfect. And I tried to send the first uplink. It was 10 bytes, so it's supposed to be okay. But in fact, the stack tried to add more bytes related to Mac commands, and the stack refused to send it because in the USA, the maximum time is 400 milliseconds. And so all my uplinks sent and never sent, in fact, due to this reason. So one feedback on this experience is the stack is returning an error code. So consider the error code and process the error code. Because if you just say, okay, the next one will be okay, it won't be the case in such situation. So in my case, the easy solution was to say, okay, if I have an error code which corresponding to a problem of airtime, in this case, I just send a 0-byte frame to make all the Mac command pending sent to the network, and then I can be back to the normal situation. That's an easy way that works quite well, but there is other way to do that for sure. Can go to the next slide. The other topic which is really interesting to take into consideration when developing device is the adaptive data rate. Adaptive data rate is really important for networks. It really helps the networks to be optimized, to maximize the capacity, and also for the device to help preserving the battery. Basically, the idea is to not sending at a too low data rate if you are really close to the gateways, and don't use too much TX power if you are close to the gateway. So that's quite good. But you need to understand that ADR is defining the that an adaptation is required, defining the protocol between the LNS and the device, and defining what are the metrics we can use for this. But ADR is not an algorithm. It did not define how the new DR, the new takes power are calculated. It's based on LNS implementation, and this can change from LNS to another. And also, your LNS can have multiple algorithms, so maybe you can have to choose this. So you have to take this in configuration. Some remark, if you do mobile device, don't use ADR. I will show you an example, quick example. And the other thing is that ADR usually does not consider the device capacity of reception and the noise around the device. So you can have some device that stop communication because they don't receive correctly the data when changing the data rate. We can go to the next slide, please. So this is just to illustrate a mobile device. I won't go in detail. We can go in questions if you want. But what can happen is that basically it's a car and a tracker in a car. On step one, we are really close to the gateway and park there. So basically the LNS learns that we don't need a high DR and a high takes power. So it reduces all of this. And so the device works well. But as soon as it starts moving, is not able to communicate with the gateway because it's too far for the configuration it has. So the idea is well made. In that case, the SF can change, but if you are too far, it's not working. And after the device, as it is not communicating, will go back in a rejoin process. And due to join back off, potentially the join can be only once a day. And so your car can make days before being able to reconnect to the network in a such configuration. So you have to understand this. And once you understand this well, basically you can use it safely. We can go to the next slide, please. So another example to explain how the difference of algorithm between LNS can be an impact. It's also a real case from the field. We had a fleet of devices running on one LNS, and inside the same network, we migrated to a different LNS, and the ADR algorithm implementation is not the same. So basically, the fleet in the initial solution was never switching to DR1. To DR0, sorry, and was switching before DR1 and DR3. And once it has been migrated, it was switching between DR0 and DR3. And as the frame was more than 10 bytes, all the American part of the fleet, far to the gateway, stopped communicating because they were switched to the wrong data rate in regard of the payload size. So it has been quite easy to fix because we just rewrite the algorithm on the LNS and it's made for it. And so the device came back. But you see that we have to consider this when we do a migration. And it's not just migrating and everything will be okay. You can have impacts like this if you don't pay attention to this. We can go to the next slide. And the other thing which is quite important is about the repetition for all frame with acknowledgement. So this is a back-off mechanism, which basically says that if you join, for example, and you don't get a response, you should not retry immediately. In fact, for any action that require an acknowledgement, for the first hour, you may have a 1% duty cycle, and it's not regulation, it's really a recommendation for the LoRaWAN implementation. And after 1 hour, it's 0.1%, and after 10 hours or 11 hours, it's 0.01%. This explains why my car has difficulties to rejoin once the communication has been cut previously in my example. So this is really important to implement this because it protects the network, as we're going to see in the example. And yes, I know that when you are a developer, I am a developer, it's really boring when you have to wait a long time for the device to connect or to get a hack. But you can have a dev mode where you do things really fast, but when you go in production, you have to switch back to the normal implementation. And honestly, in most of the cases, when the device cannot join, it's not a good point to repeat it many times. In fact, it's in many cases, like 80%, because the gateway is too close to your development device. So just move them, and you will see that the communication will be really, really more efficient in development. So some example of what we see about this, and Julian, if you go next slide, was talking about polluting. That's something we really care. Make a device that please do not pollute the radio space. And it's what I call the join maze. So the join maze is basically devices that are trying to join at the maximum possible rate. So like 1% duty cycle. Just my own experience is I'm monitoring my gateway since 2015. And the main device that is communicating now for 10 years is a device that is just doing join request like every 30 seconds. That's terrific. I don't know where is that device, around somewhere, but it's, yeah, okay, that's really pollution. So 1% duty cycle is what we can see. Have in mind that when you do that, you pollute, you impact the gateway downlink capacity because the gateway will try to respond and use its duty cycle. We also avoid reception of other device because when the gateway is answering, is doing a downlink, is not able to receive on the same time. And it also destroys your device because it's creating write flash cycle and for every session. And at the after a certain time, it can burn your flash on your device. The other side impact is every time you consume a DevNonce, and once you have consumed all the DevNonce, basically the LNS will reject your connection, even if it works correctly in terms of radio communication, because to protect your device against a security attack. And so we'll have errors like you see here. And basically the device is not able to connect until we clear the DevNonce history. So that's something which is also important to consider. But it can be worse like this. Next slide, please. If you don't correctly manage the battery end of life. So battery end of life is really something you have to take into attention. And I would say that what we see on the market is devices that are working like on my normal scenario. So basically they are starting, they are doing a join request, they are waiting for a join accept, and then every 5 minutes they send an uplink. So that's okay when the battery is okay. But when the battery is low, what happens is that the device is starting, doing a join request, immediately restarting because of battery level, and doing another join request, and that's kind of infinite loop until the battery is totally done. So maybe you're going to consider that, okay, it's going to happen like 10 times and the battery will be dead, but the reality is different. I've seen device able to do that like 50,000 times before the battery has died. So it means that really spamming the radio space because you don't have a duty cycle in this case. I mean, it's really rebooting and it can be like 50% duty cycle, and this is totally not respecting any regulation. So you can also have some trouble due to that. At the end, it also destroys the flash of the device as once again, you have flash write every time. So we have to fix that. It's really important to consider this. And if you go to the next slide, there is really a simple way to do that, is to change your algorithm to start by waiting for 5 minutes and then doing your join request and your standard loop. The main difference here is that even if it's doing the same thing, you're going to have one message per 5 minutes and not one message every 2 seconds. So that's really interesting to implement that. And once again, I know that when you are a developer, you don't want to wait for 5 minutes, but when you develop your device, you can have a developer mode and a production mode, and make sure that the production mode is active in production. Monitor your battery end of life. That's really, really, really important. We can go to the next slide and close to the last slide, which is about the security, which is quite important. Remember about the European regulation since August 2025, so now it's months ago, we have the RED, which is in place, and the RED is a part concerning the security of connected device, and it's mandatory to get the CE stamp. So any device that is developed and deployed on European market must respect the RED. There is kind of different thing in RED. But some points that are important in regard of LoRaWAN. The first is basically the red and the coming CRA that is arriving in Europe this year really requires the ability to upgrade the device to fix the problem, the CV you can have. And for this, we have a firmware update over the air on LoRaWAN to provide this at scale. And you can have a look to the TR006 for this. As part of other important things, you have the secure boot and firmware signature, which is mandatory on developing devices. And you should not be able to upload a firmware that is not signed and validated by the device maker. So the programming interface like JTAG, SWD, UART must be protected and closed. And you may not be able to do a firmware update over the cable without a firmware signature verification. The red also says that every data needs to be encrypted during transmission, and LoRaWAN is ensuring this part for you, so that's good. But you also need to encrypt data at rest for personal and confidential data. So please take care of this part, which is also important. I think I'm good for this presentation. It went a bit fast. Hope you got most of this. Julien will be back, I think. And now I think we have some time to answer a question if you have some.
Yeah, right. Thank you very much, Paul. It was really intense and really good. So thank you very much. We have a bunch of questions on the chat. So I will start with that. So don't hesitate to add more questions so that we can answer them today. And if you have more and we cannot answer them, we will follow up with you, of course. So the first one is on the beginning of the presentation, actually, Paul, and let me bring back that slide about EUIs. Uwe asked us, what's that $900 give you as a number of EUIs?
So basically, you need to have your own block of EUI 64, and these blocks are not distributed by the LoRa Alliance. Okay, it's an international standard, so you get it from the IEEE, and that's the price of the smallest block you can acquire. I don't remember; it's like million of values, but it's a minimum block you need to purchase to start numbering your devices.
Yeah, that's right. So the IEEE is providing 3 tiers, and the lowest one, the Mac S, is already good enough for making a lot of devices in it. So you can check that on IEEE website. It's quite open, and you can check that there.
Yeah, and I mean you can purchase it with, I think it's credit card number or something like this. It's quite easy basically to get it. Maybe you have to provide some IDs, but it's quite easy.
Yeah, and it's very important to use own blocks, as you said, because otherwise it's a big mess in the join process.
Yeah.
Okay, so one more question was on the slide 12, I guess, about the let me check. I don't see it now. Maybe it was on the next one. Sorry. About the mutualization of device address. Yeah. So can you explain a bit more what is device address mutualization?
Yeah. It's when you want to join the network, you get an address exactly as say as a DHCP. You connect your laptop and you get an IP address. Here it's not an IP address; it's a dev address for LoRaWAN, but it's the same ID, so you dynamically get an address. On your laptop, you must have a unique address on the network because that's the only way for your computer, your switch, and all the network equipment to make the difference between my laptop and your laptop. So we need to have one dedicated address. But in LoRa network, in fact, we can differentiate different devices sharing the same address thanks to the signature that is used with the network S key. And so thanks to this, we can reuse the same dev address for a large number of devices. So it depends on the capacity of your LNS to retrieve, to find the right device corresponding to this. And basically, it's interesting because if you have a fleet with 1 million devices, you don't need to have 1 million of dev address. And my experience is that we can use like one address for something like 200 up to 500 sometimes devices. I more recommend to have a maximum of 200, but it means that if you have like, I don't know, 2 million of device, basically you just need like 10,000 addresses, which is reasonable, I would say. And maybe you can complete this part, Julien. I mean, because to obtain this dev address, I say it's a LoRa Alliance, which is distributed the dev address, and I think you get blocks when you are part of the
Exactly.
alliance.
So exactly part of being a member of the LoRa Alliance allows you to get what we call a net ID. So it's a network identifier, which is part of the building of the device address, the dev address. And depending on your membership levels, you get either very short net ID, so very short preamble of your device address, and if you and the less you go, the larger that prefix is. It's a prefix from the address, and from that prefix, actually, it's very useful for roaming. You get the network identifier from the device is hosted on. So every device address, and actually that was one of my questions. So you're burning one of my questions, but that's good. Here we see that the device address start with 48, for instance, and I guess that's a net ID from one of the members, right, Paul?
Yeah, I think it's the old net
It's
ID
all one
Helium.
from
Yeah,
Helium,
the
right? Yeah.
old net
Okay, so
Helium
now
net
you
ID.
change that. But as you see that the device address is 4 bytes here, and you see that there is a clear prefix here with 48, which was used by Helium, but now they use a new one which is clearly allocated in our
Mm.
tables. And there you can find out and recognize a device network from the device here. And so you get a range of addresses depending on your membership level and the level of your net ID.
And it's important to not use a range from another network
Oh yeah. Mhm.
because the LNS will basically filter the traffic based on the dev address. So if you use dev address range from someone else, basically you can, I mean, text processing on this other network LNS. So that's not fair.
Yeah, exactly. Yeah, so that's part of the same as the EUI 64. You should use your own block of numbers. Otherwise, it's a device which is polluting in the sense that it's not recognized by the network it's supposed to join.
Yeah.
Okay, so one more. It's not a question, but I wanted to show that to you, Paul, because actually we have on the list of attendees the main developer of the LoRaWAN stack in RadioLib. So he wants to
Oh,
thank you for
good.
the shout out. So yeah, we encourage. Yeah, that was this slide here. So thank you very much for being here first, and that's great that we have a nice community like that.
Yeah.
Okay, so one question which is a bit more technical from Paulius. Let me go to it was on one of the last slides about the DevNonces. So
Uh,
what is the number of all DevNonces that the LNS stores for a
mm.
single device? Very interesting questions.
Yeah, very interesting, and I would say it depends. In fact, yeah, it really depends on the implementation. I mean, it should remember all the dependencies. But there is 65K dependencies, so maybe they are not recording all. But since the version 203, I think, and 204, I'm not sure if it's 102, sorry, 102 or 103, but there has been a change. By the past, in fact, the DevNonce was random. So you get random number, and the LNS has to basically store all the DevNonce. And that was a problem in security because, in fact, the LNS did not store all the DevNonce. So basically, there is a risk of replaying all the join requests with a previously used DevNonce. In 104, this is incremental. So the LNS in 104 could just store the last value. And as he knows the last value, he knows that all the previous value from 1 to the last value has been already used. So it depends of the LNS. I've seen different implementation of this, but potentially I would say that the LNS could only have to store 1 and to know that all the previous one has been registered.
And we are really in the topic of today's, because today's we are talking about this technical recommendation TR007. And actually, if you read that recommendation, in there we advise, even for devices which are a stack, LoRaWAN stack, which is under 104, which you're right, Paul, is now using incrementing numbers as nonces. We advise that you use that even if you are not mandated to by the specification. So that's one way to secure your device and to ease your deployment, is to use a counter instead of a random nonce. So the behavior will be the same, the security will be the same, but the way to deploy and to not remember all those nonces randomly will be much easier on the network side and on the device side as well. So yeah, that's really what we want to emphasize here today, is that actually that recommendation, the technical documentation you can download on the website, is adding more robustness to what you could do when you develop a device.
And a side comment related to that, because it's also a problem I see on basically on a weekly basis on the fleet I manage, is users that are declaring their device as a 104 device, but in fact they are 102. So basically the LNS is expecting incremental DevNonce, but the device is sending random DevNonce. And so if the device sends DevNonce 1, okay, join. The next time he send random value, so like 1000, it join. But the next time it's generate like 200. And the LNS say, oh, in 104, I cannot get 200 after 1000. So it is rejected. And the device have many difficulty to join because you have to retry join up to get a nonce that is higher than the highest one that has been randomly chosen previously. So this is polluting once again, because you have a join requests that are cycling up to find a good number, and it causes trouble to join the network. So that's just a simple setting you have to take care.
Yeah, a great example. Thank you. Okay, so I wanted to come back to the ADR on a mobile device, and I do have a question here. You said the car is parked and switched up to SF7, so the link quality is very good. And when it starts smoothing, you don't hear it anymore. But what about the device knowing it's moving and disabling the ADR algorithm, or maybe trying some different spreading factors? Is this something possible?
Yeah. You can tweak this. I mean, you can avoid or deactivate the EDR on the device side for sure. But I mean, I would say that it's not a good behavior, a good habit for me to deactivate. I mean, as you said it, like when it's moving, I deactivate and I create a specific profile. That's really good idea, because you get the best of ADR when you are at rest, when you're parked, and you avoid all the problem when you are moving. So that's a really good way to do it, but it's extra development and extra test. Okay, so if people don't want to go to that direction, I think that deactivating ADR is not the best way, because it's good to have ADR. So one of the solution is not to deactivate ADR on the device, but to use a profile on your LNS to deactivate the ADR on the LNS. What I mean is, in fact, the ADR always return to the device, keep in the same data rate, or I mean, which basically means do nothing with the ADR on the device. So you can also have this strategy to keep ADR active on the device for future usage, but not being in that situation.
All right, thank you, Paul. So we have one more question. It's a question about security. So I don't need to show anything, but let me ask it to you from Zaid Nuden. how the key rotation happens for devices in the field. Say app secret needs to be rotated. Can key be rotated remotely?
Yeah, I mean, you can. So a device should rejoin on a regular basis. So that's one first thing. Maybe you better know the parameter than me, Julien, on this one. So I will let you
Yeah,
complete what I say. But you can. So you can do it on the device by doing a rejoin. But you can also send a command through the LNS to ask a device to rejoin and do that on a regular basis, which is less used
yeah.
basically.
So actually, rotating root keys is not part of the protocol. It should be done
Oh yeah, yeah.
on the application layer. But rotating the session keys is actually part of the join process. So every time you join, all the session keys, so not those keys, but the one just on the next slide. So the network session keys and application session keys are completely new, and they are not linked to the previous one except with the link with the root key, so the app key. The but that's the way we rotate secrets. So like in TLS where you make a session with your website, you get session keys. Here the session key are those two keys, and these ones can be rotated. The root keys themselves, they should be rotated uh, either on the application layer. So you send a new root key to your device. You have to secure that, of course, or other means, but it's not part of the protocol because actually that would be a chicken and egg problem. How do you
Mm.
know which key to use if you need to rotate it before joining?
And to make the link with the discussion we had previously, what makes getting a new key at every session is because we have this DevNonce, which is incremented, and the increment of this DevNonce is
Mhm.
basically makes the keys totally different, even if the root key are kept the same.
Yeah, exactly. Okay, so maybe we can take one more questions about ADR. So I think that's the same one. ADR impact on mobile devices. Let me bring the slide because I think we need the step three. Someone is talking about step three. Can, after being in step three, device recover on its own and join the network again?
Yeah, so in my example, in step 6, we are joining, so it's okay. In fact, the problem in step 3 is that, so it's to illustrate that ADR is not like if you are SF7, it will not stay SF7 forever. In ADR implementation, if the device is not able to communicate with the network, after a certain time, it decides to increase the spreading factor to get more chance to join the network. And in my case, we are far away from the network, so it's impossible because I want to also show that after a certain time, due to the IDR, ACK limit, ACK delay, the device decides to rejoin. And so it starts a join process. And as we seen, there is the join back off procedure. So the first try of the two join in my step 3 are like 10 minutes, one after each other. So we try to join fast, basically, but there is no network at this place. And after we go in the backoff process, that can be like 0.01%. And so it means that we're gonna only have one try to join per day. And as we are in a mobile device, we need to be in contact with the network during that trial. So once a day, you have to be close to a gateway for this, which is statistically speaking not an evidence. So that's why there is, in my example, difficulty to rejoin. And it's really an experience I had on the field. So that's why I try to explain this. Is I really had a device, it was 10 years ago, but I really had a device that had a issue to join due to this. And so it's in my step 6 when the device stay like 24 hours close to the network. That's the joint success, and we are back on a normal process.
All right. All right. Thank you very much, Paul. I think that's a wrap. Let's give 5 minutes for people to get to their other meetings. Before we leave, before we close, yes, you will get the recording of the webinar. It will be on the website of the LoRa Alliance website. That's clearly published very soon. And you will get also the slide deck, which we presented, also the document, the TR007, which is really the root of all our discussions. So you will get all that. Follow the links. You will get an email. You will find it on yourself. I hope so. So again, thank you very much, Paul, for presenting all that. Thank you for taking the lead of this webinar. It was really well done. And thank you all for your participation. And we hope to see you in the next one.
Sure. Thank you, Julien. Thank you for all the participation. Thank you also to Chancy with backstage organizing. And we'll be happy to continue the discussion online. Don't hesitate. You can ping me on LinkedIn or whatever.
Yeah. Thank you all and bye-bye.
Bye.